Okay, so here we are for chapter 2.2 of the geometry lessons on triangles. Triangles are the first plane geometric figure that we are going to be looking at. And a triangle is a plane figure bound by three straight sides, and it is an example of a polygon. A plane geometric figure, this is two-dimensional, okay? 2D. And the other types of polygons that we will be perhaps looking at will be quadrilaterals with 4 sides, pentagons have 5 sides, hexagons have 6 sides, and so on. We will also do circles. But in this unit, it's just about triangles. One of the most important things to remember about triangles is the triangle sum theory. The sum of the three angles of any triangle is 180 degrees. So if we add up angle A, angle B, and angle C, their sum is 180 degrees. That's always very useful because if you know 2, then you can always figure out the third. Okay, different types of triangles and their properties. A scalene triangle is a triangle where no two sides are equal in length. All right, we have 3 different lengths. That also means we have 3 different angles. An isosceles triangle is a triangle with 2 equal sides, and that's often shown by these 2 marks to say, yes, those 2 sides are equal. If those 2 sides are equal, then the angle that they make with the third side on both sides will be equal angles there. That's isosceles. An equilateral triangle has 3 equal sides. Here it has been shown with little ticks to show these 3 sides are equal. If all 3 sides are equal, then all 3 angles must be equal. If all 3 angles are equal and they have to add up to 180 degrees, then each one must be 60 degrees. And the fourth type that we'll focus on right now is a right-angled triangle where one of the angles is 90 degrees. In particular there. The special thing that happens in this case is any right-angled triangle that will have a side opposite the right angle that is called the hypotenuse. The other 2 sides will be shorter than the hypotenuse, and we sometimes refer to them as the legs. But the hypotenuse is always the longest. An altitude in a triangle is a line from any vertex to its opposite side, and it is perpendicular to that side. So in this diagram, we have 3 altitudes drawn with dotted lines here. From this vertex to the opposite side and perpendicular to it. This line is an altitude and it is perpendicular to this side. Altitude can also be known as height. So when I refer to a height in triangles, it must be a length that goes from a vertex to an opposite side and perpendicular. Height and base are then related in this way, that they are perpendicular to each other. So often we will see that in a triangle, we have to find the height of the triangle, also known as the altitude. We will drop a vertical down and make it perpendicular. Sometimes that isn't possible to do inside the triangle, as in this case, and so we must do it outside the triangle and get a perpendicular line there. Extend the base out and make it perpendicular. The perimeter, or the distance around the outside. Okay, perimeter is distance around the outside, is the sum of the three lengths of the triangle. And the area is base times height divided by 2. Remember, base and height must be perpendicular to each other. Okay, so these are perpendicular lengths. This formula you might have also seen written this way as 1/2 base times height. Another formula for finding the area of a triangle is called Hero's formula, and it is used when you know all three sides of the triangle, the lengths of all three sides. Those three sides are lengths A, B, and C. Before you can use the area formula for Hero's formula, you first have to calculate S. S is the sum of the three sides divided by 2. And then you must sub it into here. And once you have S and A and B and C, then this formula will calculate area. Now, if this one is new to you, I highly recommend that you practice putting it into your calculator. You really want to make sure that you tell the calculator to do the square root of this whole product. So if you're finding errors when you do it, it's about how you're telling the calculator to calculate it. So I would multiply these four numbers together, set equals, and then do square root. That's the safest way to do it. This video is going to give you a chance to practice that. So Hero's formula is used when you know all three lengths of the triangle. Pythagorean theorem helps us to find the length of one unknown side of a right triangle. Okay, Pythagorean theorem is only for right triangles. And in right triangles, we have a hypotenuse, and then we have two shorter sides. The hypotenuse squared is equal to the sum of the squares of the two shorter sides. If you need the length of one of the shorter sides, then you must rearrange this formula. For example, if I want to solve for a squared, it must be equal to, well, b squared's got to go to the other side of the equal sign, right? C squared minus, and that's a big E, b squared. Okay? Always start with the hypotenuse first. It's the largest. When you square it and you subtract the square of the other, you will still get a positive number, which you will then be able to square root. Okay, now it's time to pause the video and practice these two questions. In this first question, what is the measure of angle A in a triangle if ABC, and triangle's name is ABC, if angle B is 47 and C is 74? Well, this makes use of the triangle sum theorem that the sum of all three angles are 180 degrees. So we must say that angle A is 180 minus 47 minus 74, which is 59 degrees. Find the area of triangle XYZ with a base of 27 centimeters, a height of 12 centimeters. Well, the formula that we saw that finds the area of a triangle and uses base and height was area equals 1/2 base times height. So 1/2 times 27 times 12. This is equal to 162 centimeters squared. Notice I am multiplying centimeters by centimeters, giving centimeters squared, which makes sense. It's an area. It should have a square unit. All right, in this question, you are going to pause the video again and find the area of an isosceles triangle with equal sides measuring 9 meters and the third side measures 5 meters. If necessary, in geometry, it's always very helpful if you draw the diagram. So go ahead and do that. Remember that in using Hero's formula, you have to calculate this first and plug S into here. All right, pause the video, give it a try. Okay, so this is an isosceles triangle. It has 2 equal side lengths and 1 that is not equal. The sides that equal each other are 9 meters. And the last one is 5 meters. All right, we could call them A and B and C. It doesn't matter what name we give them. So first, with Hero's formula, we must calculate S. And that is 1823 over 2, which is 11.5. And that would also be meters if you want to attach a unit to it. All right, so area then, we must do the square root of 11.5 multiplied by 11.5 minus 9. All right, so square root, I'm not sure where this is, maybe just a minute. So that comes from 11.5 times 11.5 minus 9, 11.5 minus 9, 11.5 minus 5. Remember, to get your calculator to produce that, you need to square root the whole product underneath here. So make sure you are giving it your calculator the right information. Practice the Pythagorean theorem. Pause the video and find the length of this unknown side. With Pythagorean theorem, it's very helpful to establish first whether you are finding the length of the hypotenuse or a shorter side. That means, am I using c squared equals a squared plus b squared, or am I looking for a shorter side, a or b? Now, since this side is opposite the 90, it is the hypotenuse. It is c. So c squared equals 14 squared plus 10 squared. And when we square root that, we get 17.2. I will just finish these values here. This is 196 plus 100. C squared is 296, and then C is the square root of 296. Okay, and this one is going to be equal to 24. All right, sorry to rush this last question. I'm running out of time with this video. I suggest that you try this practice, post it in the slides, and see how that works out. Thanks for watching.